Given a general form of a second PD in the function of u, in the function u of two independent variables x and y, a x y partial square u all over what partial x square plus bx comma y partial square u all over what partial x. So is a partial the x the y. This is a partial derivative as an independent plus c x to the power of y the square u all over what the y square plus f x comma y comma u the square u the x the square u the y is equal to 0. When the equation above is said to be elliptic, parabolic, hyperbolic, and give two examples each, it means this function of a comma x comma y is affecting this, and this function of b is affecting this, and our c should be what? The y square. So it means for a function to be an elliptic, for this equation to be an elliptic, an equation is said to be elliptic if b square minus 4ac is less than 0. And we got our b square minus 4ac as a discriminant method. So when we talk about discriminant method, because it's from what? A quadratic equation. We can use this or we said or b square minus 4ac is less than 0. Either of the two. And for this one to be for this equation to be an elliptic, it must be in form of the square u all over what? The x square plus the square u all over what? The y square. And if this equation is in form of this, it means this equation is an elliptic where where a is equal to 1, b is equal to 0, and c is equal to 1. It means if our a is 1 here, 1 will multiply this one, I'm going to have the square u over the x square. Plus, if our b is 0 here, 0 will multiply this one, all here will be 0. So, it is not needed. And if our c is 1 here, if I multiply this one by the square u over what? The y square. So, I'm going to have what? I'm going to have 1 here. So, this one will not be the square u over what? The y square. So, that's why they have the square u over the x square plus the square u over the y square. So a good example of this, whenever we have something like this, function of this, we call it as what? Laplace equation. So an example of epileptic equation is called what? Laplace equation. Where a is equal to 1, b is equal to 0, and c is equal to 1. If I put in a is equal to 1 here, b is equal to 0 here, and c is equal to 1 here, our answer here will be less than 0. So that is what this one means. So let us our b is what? 0. So b square minus 4ac. A is 1, b is 0, and c is what? 1. So let me substitute inside it. I'm going to have 0 square minus 4 times 1 multiplied by what? C. So I'm going to have 0 minus 4. I'm going to have minus 4. So we have minus 4 and 0. So which one is less than? So it means minus 4 is less than 0. So it means minus 4 is less than 0. Otherwise, 0 is greater than what? 0 is greater than what? Minus 4. So that's why we have b square minus 4ac is less than 0. So an equation is said to be an elliptic if b square minus 4ac is less than 0, or use capital letter. And it must be in form of this: the square u over what? The x square plus what? The square u over what? The y square. Where our a is equal to 1, b is equal to 0, and c is equal to 1. So an example is what? Laplace equation. Laplace equation. And a Laplace equation is in form of this. Also is the Poisson equation. So let us consider when an equation is said to be what? Parabolic. Parabolic. An equation is said to be parabolic is said to be parabolic if b square minus 4ac is equal to 0. If you have b square minus 4ac is equal to 0. If you have a as r square, we have b as 0, and we have c as well 0. So how can this second PDE be a what? Be a parabolic? So it means if I come here, the square u over the s square. Whenever I see a, I put r square. What am I going to have? I'm going to have r square, the square u over the s square. So if I go to b, so it means my b is what? Having is what? Coefficient of b is what? That is, my coefficient of b is b the square u over the x the y. And if my b is 0, is 0 the square u over the x the y. And my c is 0, the square u over the y. So 0 multiplied by this one goes to r square the square u over the x square. So and so we have considered that what the second PDA must be what? The second PDA must be a parabolic, that is an equation is said to be parabolic if b square minus 4 is equal to 0. And we have this. We always arrive to this one. So and a good, let us now consider a as r square. Let us plug in here. Is b square minus 4ac will be equal to 0. So it will be b square minus 4ac. So what is my b? My b is for 0 square minus 4. What is my a? A is r square. And what is my c? 0. So 0 square, I'm going to have 0 minus 4 times r square 0. This one is 0. So minus 4 times 0, I'm going to have 0. So 0 minus 0. You can see that what? My b square minus 4ac equals what? B square minus 4ac is what? 0. So here 0 is equal to 0. You can see that what? A parabolic equation. An equation is said to be parabolic if b square minus 4 is equal to 0. And a good example of this. So an example, if you have a function in form of like r squared the square root by the x squared, I'm going to have what? It equation. It equation. So this is an example. This is how this equation is different. So let us now consider our last example, our last question. When an equation is said to be what? Hyperbolic. Hyperbolic. An equation is said to be hyperbolic. Hyperbolic. If b square minus 4ac is greater than 0, if this is greater than 0, my what? My equation is what? Is what? Parabolic. So let us consider if our a is equal to what? R square and our b is 0 and c is what? Minus 1. What am I going to have? It means I'm going to have what? R square, the square u over what? The s square. That is, a is R square. Then my b is 0. I'm not going to input it. Then my c is minus what? Minus the square u over the y square. And if you have something r square, the square u over the x square minus the square root of the y square. This is a del. It's a delta. It's a Greek letter. So it's a delta. So it means if you have something like this one must be r square minus one because what must be greater than what? 0. So it means what? It's an hyperbolic equation. And this an equation is said to be what? Hyperbolic. And a good examples of hyperbolic equation. An examples of hyperbolic equation is wave equation. An examples of hyperbolic is what? Wave equation. If you plug in a as r square, b is equal to 0, and c as minus 1, b square minus 4ac will be greater than what? Will be greater than that 0. So this is how this when the equation is said to be what? Elliptic. And the equation is said to be elliptic, and the equation is said to be parabolic, and the equation is said to be hyperbolic. So this is how to solve. So this is how an equation is said to be in second PDE.